Hello scholars, are you ready to have a look at number 4 of your Module 1 course overview Excel report? We are going to look at creating a bell-shaped curve. So we have a set of data reported by the College Board of SAT scores from the early hundreds, or thousands, I mean. This is like the year 2000, 2001, 2003. And it's normally distributed with a mean of 1,068 and a standard deviation of 230. And the instructions here are to create a bell-shaped curve using the data. And here, there's a YouTube video here. This is where I learned how to do this just a couple hours ago now, earlier today. And this is a really great guy. You might want to save him to your favorites. I subscribe to his station. I love his Excel videos. He's called Mr. Excel, and he's pretty rockin'. Easy to understand, with a very pleasant voice. All right, so let's look at what else? The percentage of students who scored. We'll look at all that here in a little bit. Let's go ahead and get started with creating our chart. Labeling number 4 here. I'm gonna keep this small. I know it's hard to see. I guess I'll make it small when we get to that point. I am gonna need a lot of space here. I'm just gonna go ahead and record my mean and my standard deviation, just so that I have that data. And it was 1,068, and my standard deviation, I'm gonna go ahead and put a font 10 here. Stand Dev. I just made it 10 font because it goes over just a little with 11. And my standard deviation is 230. And then I am going to center all this stuff just because I want to. And heck, I'm even going to surround it with a little borders and label that blue. All right, now what I have to do is create a very long set of data. I am trying to find the values that are going to go in. You see this bell-shaped curve right here? By this point, you guys should have looked at the bell-shaped curve. You had presentations. We did activities in class and some other things. Those of you on the online course, you've watched videos, written reports, summarized, all kinds of different things. So the bell-shaped curve should be something you're familiar with. And I know that the center value is my mean, which is notated by the Greek letter M. We call it mu. And then we have our standard deviations. Our standard deviations tell us how spread apart the data is, which you inferred, or not inferred, but learned that in number 3. And we know that the first standard deviation is the mean plus the standard deviation and the mean minus the standard deviation. The second standard deviation is the mean minus 2 times the standard deviation. And then on the right-hand side, it's the mean plus 2 times the standard deviation. So all I'm going to do over here in Excel right now is I'm going to go ahead and create a little chart to record that because I need these values for what I'm about to do. So I am going to create a little, first I'm going to make these bold. First I'm going to actually notate what I'm doing. I'm going to do first here the mean minus 3 standard deviations. I'm actually creating this little bottom piece right here. I am going to insert a symbol. In your Greek alphabet, wherever you start on this thing, you just scroll down until you find your Greek alphabet. It's about a quarter of the way down on mine. And you'll just start seeing all of those Greek letters. If it's Greek to you, then you're in the right place. Ha ha ha. Where are they? Did I not go down far enough? Here we are. All right, so here are the symbols. Mine are already down here because I use them. But I want you to see where it comes from. So here I have my mean. I'm going to insert that and then I can't just type minus or anything. I would have to click out of this and come back. So I'm just going to go ahead and grab my sigma while I'm here. I do want to point out that the Greek delta symbol is very similar to the sigma. So it's not that it's a huge deal for what you're doing here, but this is your sigma, and I'm going to insert that. All right, now I have to close that, and I'm going to come over here and do minus 3 times sigma. You see right here, it's the mean minus 3 standard deviations. That's all that means. I'm going to use this. How many do I need? 7, 2, 3, 4, 5, 6, 7 of those. My first one is the mean minus 2 standard deviations. This is the mean minus 1 standard deviation. We do not record the 1. The 1 is what we call a multiplicative identity in math. Anything times 1 is itself, so we do not record it. You might remember that from your algebra days. And then on this side, it's the mean plus 1 standard deviation. And then we have the mean plus 2 standard deviations and the mean plus 3 standard deviations. All right, again, I am going to make all of these cells centered, and I am going to bolden these top cells and even make them blue because I just like stuff to look good. I'm also going to border those. All right, so now I am going to select these values over here. I have the mean. I need to put my equal sign in there, and I have the mean minus the standard deviation, minus what? Minus 3 times the standard deviation. You guys see that? And press enter. So now I get 1068 minus 3 times 230. Kind of taking a risk here, but I'm going to show you guys something. Remember how we do cell referencing? Going back up here to number 1, when I referenced here, I referenced the cell to the left when I referenced Bravo 6, and then Excel automatically referenced Bravo 7, referenced Bravo 8, Bravo 9, and so on. As I drug the cursor down, it referenced the cells to the left corresponding to the position where I was dragging it down. So let's look what happens here. I want to use this information because all I have to do is change this 3 to a 2 and delete it here. So I'm going to recycle my information, but look what happens when I do that. I do not get the right values because, well, for a couple of reasons, but what's happening is right here, look, Excel referenced these 2 cells. It skipped a cell and then referenced those 2 cells. So what did it do for this one? Same thing. It skipped a cell and then referenced. Do you see what's happening here? How this referenced delta and echo, because it's dragging along with me as the corresponding cells to that first cell. So what I'm going to do to keep that from happening is, first of all, I'm going to undo what I just did there. Now I am going to what we call do a lock. I'm going to lock these in place, which means that when I drag it, I want it to continue using just these 2 cells. And I do that by using a $sign. Why a $sign? Well, heck, I don't know. I assume that the reason it's a $sign is because by the time they realized they needed a cell lock symbol, there really probably weren't lots left. It's a nice, comfortable place on the keyboard. So whatever the reason is, I don't know. All right, now I am going to drag this across, and I should end up with the same value in every cell. Perfect. All right, things that are going to change. This one is 2 standard deviations, not 3. Enter. This one is 1 standard deviation. I can just change that 3 to a 1, or I can delete that. This one is just mu, no standard deviation, so I can delete all that. let's see, this one is a +1. So change all that to a plus, enter. This one is +2. And this one is +3. All right. All right, now I see that from 3 standard deviations to the left of the mean, my number is 378, and 3 standard deviations to the right of the mean, my number is 1758. So, let's see, what I have to do now is I have to create a set of numbers from 378 to 1758. Remember, you guys, this is practice playing with Excel. When we get to this module, we'll look at more stuff. I just want you guys to be familiar with all the different ways to use Excel, the different ways to click, and all the cool stuff we can do. All right, so this is a really long set of data, and I still have to make a pie chart for the last 2 problems for numbers 5 and 6. So because I have to go down so far, you'll see here in a minute what I'm talking about. I'm going to leave myself plenty of space down here for numbers 5 and 6. So I'm going to actually go ahead and do this over here. All right, so I need to create all digits from 378 to 1750. If there's an easier way to do this, I do not know what it is. 378, and then I'm going to write in the next cell 379. And then I'm going to select those 2 cells, and this takes forever. 1758, don't forget that number. I'm going to drag this all the way down to 1758. You see that number changing to the right? It's in the 600s. I'm taking that number all the way to 1758. I don't know how many cells there are in Excel. There is like a certain number, but it's over 1 million. 1758. I don't want to forget that number. You just kind of hurry up and wait for it to scroll. Looks like I'm getting somewhere. Once I establish this, I won't have to keep scrolling. I learned today by watching another video. All right, we're getting closer. Was it 1758? I sure hope so. If not, I'll come back and add some. All right, 1758. There we go, folks. You see it? All right, now I have to get all the way back up to where I was working. All right, now I am going to create a standard normal distribution. So I'm going to press equal, and I'm going to type in the word normal, and I'm going to go with a normal distribution. And my normal distribution wants my x value, which is going to be every single number to the left here. All of these numbers are going to get drugged down to create a set of data. So I select that value, comma. Now it wants my mean, comma, my standard deviation. But don't forget, once I drag this all the way down to get that x value, it's going to also drag it all the way down to get my mean and my standard deviation. So I have to lock those cells. And we just do that by sticking a $sign before and after the letter part of the address. $sign, $sign. I use my arrows on this, but sometimes it confuses Excel and does weird stuff, so $sign. And then we have the last part of this, the cumulative part. Well, no, that's false. We're going to keep using false here. Close parentheses and enter. Now, remember how we had to drag this down before? I didn't actually learn this until I was looking up some stuff about your little summary about the relationships for number 3. That's where I learned this. Now that I referenced that cell to the left, instead of dragging this down, I can actually just double click on it. But my cursor has to be right. That's not the right cursor. I don't know if white will, if my cursor's white and I double click, then that's what I get. So I do have to have my cursor as that little black cross, and then I click, click. You ready? Click, click. And I can prove it to you, even though I don't want to, but it does actually stop where my data runs out. Pretty cool, huh? All right, so now I am going to select all of this data, which again, I can just do the click, click. Yay. And then I am going to insert a scatter plot with smooth lines. Whoa, look at that. Isn't that amazing? This is so cool. All right, so here's my scatter plot. You can see, look at my mean. It is right where it said it was. I'm even going to take this little chart that I created, and I am going to drag it right down here. I don't know, is that going to work? I guess I can kind of move this over. I said 1200, I meant the 1068. But I can just move my graph over down there, and I can do all kinds of other cool stuff. But then, of course, you do want to label this. These are College Board SAT scores from the early thousands. Sorry that you cannot cut and paste that like I can. You'll just have to type it in. College Board SAT scores in the early thousands. I want to close this out. I'm going to add some labels. My access titles are very important. I always have to have my graphs and charts labeled for my story. And these are the, what was this value? These are the actual scores. Is that what it was? All right, and what do we name the y-axis? That is what I want you guys to find out, what that y-axis is going to be called. Make this a little bit bigger here. All right, now I am going to do some other stuff. I have some other questions to answer for this problem. I've created my bell-shaped curve. Everything's looking really good here. I love how it looks. I can even fancy up my design a little bit if I want to. I have all kinds of different things I can experiment with. What's this fuzzy looking thing? Oh, definitely don't want to do that. Oh, thank goodness it did not ruin anything. All right, so let's quit playing for now and just keep on with the video. So it says, what percentage of students scored over 608? Well, you guys see this bell-shaped curve here, and here there's probably a good way to label this accordingly, but what we're going to do is we're just going to use our little chart down here. There may be a better way to do this using the graph that I don't know about. But let's just go ahead and I'm just going to grab this image. Oh gosh, you guys want me to show you something really cool? I am going to use my Snippet Tool. You see this little Snippet Tool down here at the bottom of my screen? You can find your Snippet Tool by clicking your window and typing in SNIP and getting your Snipping Tool. Well, actually what I would have liked to show you to do here is type in your Snipping Tool, right click on that, and then pin it to your taskbar. Mine's already pinned, so it says unpin, but pin it down there because you are going to use that a lot. If I haven't already showed it to you in a previous video for your presentations, it's such a fantastic tool. So I'm going to grab that tool, get a new snippet, and I'm just going to snip this little bell-shaped curve and put it right in here. Because what I want you guys to see is the percentages. Do you see that within the first two standard deviations, that's what this means. Actually, I should have snipped a little bit more so that you can actually see the standard deviations. But each of these things, when I say things, what I'm talking about is these spaces down here. This is the mean, and then you have the first standard deviation, the second standard deviation, and the third standard deviation. So everything within the first two standard deviations covers 68.2% of all of the people, or all of the scores, or all of the flowers or dogs, whatever it is. These numbers always stay the same. But I'm teaching you Excel here, not a lot about this because you've already explored all of this. So I know that 64.2% of the data lies within the first standard deviation. And then I add 26 plus 12, right? 26, 36. So then I add the 38% here. Is that right? 38. And then, or 1.2 it was. I'm sorry, that's 26, so that's 27.2. Anyways, we're going to let Excel do that math for us. So, trying to find a place to put this. I'm just going to delete it. Just wanted to show it to you. Let's see. We want to know between the percentage of students who scored over 608. Well, here's 608. 608 is in my second standard deviation to the left. I'm going to actually put this back because I need it. So right here, let's see what that looks like. I'm going to do some calculations. So I'm just going to write right here, calculations. Or let's see, is there another place I can do this? Well, it doesn't matter. We'll just do it right here. Calculations. All right, my first calculation, I need to know everything from 608. So that's from this second standard deviation, everything. All of the students who scored over 608. So that was this percentage plus this percentage plus this percentage and so on. So what do we have here? I have two 13.6 percentages plus two 34.1 percentages. You guys see what I'm doing? Move that cursor. Plus, well, you really can't see it that good, can you? Because it's so small, but I can't really make it that much bigger. Let's get back to this here. All right, so where were we? We got our 13s, we got our 34s, two 13s, two 34s, plus, what else? 2.2 plus 0.1. All right, guess what that means? It means 97% of the students, and you know what else I can do? I can even put a percentage there. No, I can't, because in that case, I would have had to tell Excel previously that it was a percent, but I have it 97.7%, and I can actually still use the percent and move my decimal or, divide it by 100. However, many ways I can do that. So here I have the percentage of students over who scored over 608. Now I want to know, out of every 460 students, how many would be expected to score between 838 and 1298? let's write this here. This is scores over 608. And then here, let's do scores between, what did we say? 838 and 1298. All right, I am going to format this and wrap it, if you didn't already guess. I'm also going to center all this stuff. This and all this, I'm going to make it bold and blue. All right, so, oh, golly gee, when it's not outlined, it drives me crazy. I need my borders. All right, scores between 838 and 1200. Well, what are the values there? Well, 838 is within the first standard deviation. So what's that right here, this line? And then the other value was 1298, which is within, so I'm just looking for this percentage right here. This is just 64.1. I mean, I don't even need Excel to do any calculations. 34 plus 34 is 68, and 0.1 plus 0.1 is 0.2, so 68.2. I'm not sure what I said a second ago, but that's what I meant. So, or we can just say that we have 2 times 34.1. All right, so now we know that 68% of the scores were between those two values, between 838 and 1298. But the question is, out of 460 students, how many would be expected? We're going to inference. We're going to use this information to make an inference about these 460 students. So what does this look like? How many scores between, and I'm just going to grab all this. How many scores between 838 and 1291 out of 460 students? And I better use the word expected because that's all statistics are, folks, what we expect to happen. So how many scores are expected? How about that? Are expected between those values. I know you're all out there saying wrap it. So select, format, and wrap. And then, of course, I've got to center it. And I want to make it bold and blue. And I want to include it in my borders. All right, how many are expected? Well, I expect 68.2% of 460. Easy enough. Equals this amount, 68.2%. Well, I can put percent. There are a lot of things I can do here. I'm going to go ahead and just type it in to remind you guys that that was 68.2%. And in order to use it for multiplication, I move my decimal 2 places to the left. So that's 0.682. And there are other things that I could have done here. When I did my calculations here, I could have used a percent, moved my decimal, and then included the percent symbol, different things that I can do. All right, so equals 0.682 times 460. So 68% of 460 is 313.72. So we would expect about 314 students to score between these two values. Now, folks, I am going to leave you to insert a text box and write a little report about this data. Talk to me about the scores here, how many students scored, and tell me about the standard deviation and the percentages. Just give me some information about the problem that we just solved. All right, we have one video left for numbers 5 and 6. So I will be seeing you again here in just a moment.